Hi, Algebra 2 friends. This week we are going to learn how to simplify radical expressions and rational exponents. So with the radical expressions, we will be building on things that we've been doing all year. And the rational exponents is just learning a new format for writing and evaluating our exponential functions or expressions. So let's start with just a quick little centering activity or question. And if I were to ask you what is the side length of each figure, see if you can come up with that. So we'll start with the side length of the square, knowing that the area is 25 square inches. That's right, the side lengths are 5 inches, and we know that because the square root of 25 is equal to 5. Okay, so we see square inches, and we know to undo that, we have to take the square root. Let's move on to the cube. If I tell you that the cube has a volume of 216 cubic inches, what would each side length be? So think about that one. Yes, it would be 6. Okay, because we have to figure out what times what is equal to 216. And so we know that each side has a length of 6 inches. We know that because 6 times 6 times 6 is equal to 216. Or another way we can think about this is the inverse of cubing is to take the cube root. So if I take the cube root of 216, I will get 6. So this week we're going to be looking at all the different types of roots we can take. So we're not just limited to square roots, cube roots. We can take fourth roots, fifth roots, and so on of any number. All right, so here's our question. How do I write radical expressions? So the way we can write it is if we start with a is the nth root of b if a to the power of n equals b. So notice we're talking about roots here. We are not talking about factors. Okay. The nth root of a real number a can be written as the radical expression n root of a. We consider n to be the index. So that's a new vocabulary word. N is the index and A is the radicand. When a number has more than one real root, the radical sign indicates only the principal or the positive root. So unless you are specifically told to find all roots, you're just going to assume that you need to find the positive, which falls in line with what we've been learning this year. So this year it has been very common to come across finding the square root of things. So if I say, what is the square root of 36? You would say 6. If I said, solve this equation, if I say, solve this equation, and you know you have to take the square root of each side to do so, when we're told to solve, we know that x can be both positive and negative 6. If I look at this example here of the square root of 36 and apply the vocabulary that we're learning, the index is whatever number you see right here. When you don't see a number, the index is 2, and then 36 is my radicand. Now, when we were asked to find all roots, so when we were solving, notice we came up with a positive and a negative. Let's look at the different situations of what the indices are and how many roots you can have. So we'll start with this first line here. So if you have an odd index, so let's say you're finding a cubed root, there's only one real root. If you have an even index, so a square root, and you're taking the square root of a positive radicand, you'll have 2 real roots. So the square root of 36 is positive 6 and negative 6. If you have an even index, so a square root again, and a negative number underneath, so the square root of negative 36, there are 0 real roots. There are only imaginary roots. And if you're taking the root of 0, whether it's a square root, a cube root, any one, okay, it's always 0. There is just one answer. So we're going to use these rules to help us find all the roots for different types of numbers. So first thing we're going to be asked to find is all the 6th roots of 64. So the way I would write this is the 6th root of 64. And what this means is I need to find what to the 6th power equals 64. So go ahead, try a few things in your calculator, see what you come up with. And it's 2 to the 6th power equals 64. So this is equal to 2. But notice it says find all the real roots. We have an even index and a positive radicand. So come up here. Even index, positive radicand. There are 2 real roots. So the one that we're missing is negative 2. Because I can take negative 2 to the 6th power, and I'll have a negative 2 times a negative 2, which is positive, another set, which is positive, and then another set, which is positive. Okay? All right, a couple more. We are going to find the cube roots of negative 216. So the way we write this, cube root means 3 of negative 216. So what we're being asked to figure out is what number can you raise to the 3rd power and get a negative 216? Well, think about it. I have 3 numbers. They're all the same, and I'm going to get a negative answer. That means they all have to be negative. A negative times a negative is a positive, but then that 3rd negative turns it negative again. So it's going to be negative, and then again, grab your calculator, try a few things. What to the 3rd power gives you 216? It's 6. We already did that at the beginning. So there's just one answer, and it's negative 6. All right, last one. We are going to find 4th roots of negative 1024. So what can you raise to the 4th power to get negative 1024? So we're going to have something that's multiplied 4 times, and we are going to come up with a negative answer. Is that possible? Nope. So there is none. There is no solution. Okay, now we've learned lots of properties early on in the school year of square roots, and all of those properties hold. So we can simplify these radical expressions using the same methods we used then. So in this example, in this chart, we see first the product property of roots. So what I can do is I can break this down. So if I have the cube root of 16, I can get it in its simplest radical form by breaking it down into what are perfect cubes I can factor out. The quotient property, okay, just like we learned before, if you have the square root or a cube root or a 4th root of a fraction, you can then just take that root of the numerator and the denominator separately in order to be able to simplify it. Let's try a couple of these together. So let's look at letter A. And it looks like we're going to use this product property here. So what I'm going to do is I am going to break this down and take the 4th root of each part separately. So I'm going to take the 4th root of 81, and then I'll take the 4th root of x to the 12th. So the 4th root of 81, what can I raise to the 4th power to get 81? Oh, it's 3. So this is equal to 3. Notice it says assume all variables are positive. It doesn't have directions that say find all the roots. We're just going to work with the positive numbers here. Now I have to find the fourth root of x to the 12th. So I need to figure out what can I multiply by itself 4 times and have it equal x to the 12th. Well, I know they're all going to be x's, okay, because they're all going to have the same base. But if I just have x times x times x times x, that's x to the 4th power. Because remember, our rule is we add these exponents. So what exponent would they all have to have in order for you to have 4 of them and add up to 12? They would all have to be an x cubed. So this is equal to x cubed. Put these together, and our answer is 3x cubed. Now let's pause a second though and take note of a shortcut. We were asked to find the fourth root of x to the 12th, and we came up with x cubed. What can you do with the numbers 12 and 4 to get an answer of 3? You can divide it. So when we see this, all you need to do is take your exponent in your radicand and divide it by the index, and then you'll have your solution. We'll get the opportunity to try that in our next example. All right, this looks like we're going to use the quotient property. So I'm going to break this down, and I'm going to look at the fourth root of 16x to the 8th, and then I'm going to look separately at the fourth root of 5. All right, the fourth root of 16. What to the 4th power gives us 16? 2 to the 4th power. Okay. Now remember that shortcut we just saw. What can we do with this 8 and the 4? That's right, we can divide it. So I can get an x squared there. 8 divided by 4 is 2. Now we'll tackle our denominator. What can you raise to the 4th power to get 5? There are no integers that you can raise to the 4th power to get 5, so we cannot simplify that any further. However, we learned that it is not simplest radical form to have a radical in the denominator. So even though we can't take that root, we can still simplify it further. So in order to simplify it further, I need to multiply this top and bottom by the fourth root of 5. Now when we were working with square roots, we multiplied it just once because we had a square root and we needed 2 of them for it to cancel. Right now I have a fourth root. I need to have 4 fourth roots of 5 in order for it to cancel. So right now I can see in my denominator 1, 2, 3. I need to multiply it by 1 more. And now I have 4 fourth roots of 5. So that is now equal to 5. So my denominator is now 5. My numerator, I have to multiply together 2x squared times these 3 fourth roots of 5. So 5 times 5 is 25. 25 times 5 is 125. So 125 goes underneath the radical, and I have my index stay the same. So this is now the simplified answer. All right, I have some extra practice here for you to try. There are, let's see here, 1, 2, 3, 7 of them. Go ahead, give these a try on your own, and I will have the answers for you to check when you start your next video.